Now we're going to look at our last learning objective for our first learning module. So we're going to focus on the pitfalls. And in order to identify the pitfall is that you need to understand everything we're learning about pitfall is allow you to developing a better critical thinking ability. Regardless, you're going to become data analysis or business analysis down the road in your personal life as you are reading the all kind of news. And you need this kind of critical thinking. You need to ask yourself, hey, those data they cited, are they falling to this one of the pitfall we're going to look at? Okay, so we talk about here, statistics is an essential part of the critical thinking because it allows us to test an idea against empirical evidence, right? So for the empirical data, represent data collected through observation and experiment. So our statistical tools are used to compare prior idea with the empirical data, but the pitfall do occur. As I said, we're going to go through each pitfalls, and as I go through them, you can start to thinking about in your daily life. As you're watching different kind of news, they'll start citing the data. Are you able to question those data, their conclusions, because they are part of the pitfall we're going to going through here. Okay, so the logical pitfall abound in both the data collection process and the reasoning process. So the pitfall 1 is called the conclusion from small samples. So always be careful about making generalized from small sample. For instance, a group of the 10 patients who show improvement, and you cannot say, hey, whatever the operation you did on the patient works, because you only had the 10 patients. It's such a small sample. So when do you consider a sample is not too small? So the rule of thumb is 30. Okay, so anything below 30 we'll consider a small sample size, no question. So once you start getting more than 30, more than 50, the better. Okay. So there was an example I saw before, and in our university report, not our university, some other university report. So they said, hey, we have our performance for this major is getting better because we got a student 100% achieve the meeting scores. And then when you look at the sample, you only had 2 students. So can you really see getting that conclusion? That would be a big question mark, right? So always gonna ask, hey, what is your sample size before you get in this conclusion? The small sample size conclusion cannot be used to representing the bigger population. The pitfall 2 is conclusion from non-random samples. So always be careful about making generalized from the retrospective study of specialized special groups. So for instance, here studying the vaccine-related complication must also include those who have no complication, right? So it's almost like a if you are sampling, everybody got vaccine, but when you sampled and everybody in this group all have complication, so that doesn't make sense, right? So you want to make sure you have this randomness involved when you're collecting your sample. And the pitfall 3 is conclusion from rare event. Always be careful about drawing the strong inference from the event that are not surprising when looking at the entire population. So for instance, winning the lotteries. And so you cannot say, like I mentioned about lottery here, you cannot say, hey, I'm looking at the whole United States population, hey, somebody gonna win the lottery. Yes, of course, because it's not surprising when you look at the entire population, but when you're actually thinking about, hey, is Dr. John gonna win the lottery? So the chance would be, maybe 0, right? So when you look at the large population, you know that gonna definitely happen. But when you are thinking, hey, since in the United States, we're going to win the lottery, so Dr. J is going to win the lottery. So that would be a wrong conclusion, right? So this is what we call conclusion from the rare event. Because when the sample size is large enough, even a rare event going to happen, okay? So the fourth pitfall is called poor survey method. So be careful about using poor sampling method or vaguely worded question. So for instance, anonymous survey or quiz may provide better insight. And so if you ask people about their salary, and so in your survey said what's your salary, but if at the beginning of the survey you said what's your name, and people will hesitate, you're going to judge them if they leave their name. You are matching the name with the salary they earn. So therefore, that be considered a poor survey method when you require people to leave their name. So most of the survey nowadays you see is that they don't say, hey, we don't trace in your IP. We will not reveal your names. because if you do require that, people might lie in their survey, right? So if your result is collected due to your poor survey method, and then the result will be not reliable. So they will be considered the fourth pitfall, right? The fifth pitfall is assuming a causal link. It is a common mistake people make. So as we are doing a lot of statistical analysis in QBA 2 and 3, we are not learning any statistical method that can prove causal relationship. Everything we're doing here is focusing on the correlations. So you're going to question, hey, Dr. J, when the drug industry, they do find the cause, you eat this pill and then you will be cured, right? So it's a causal relationship. That is relying on called a randomized experiment design. So it's rely on a special design in order to prove the causal link. So without that specific experiment design, you cannot prove causal link. So, but I want to also add one new development in the statistics world, especially in the economics world, we call the causal inference. So we can do the quasi-experimentation to prove the causal link. Again, that is not the scope of the learning in this class. So here we will cover the correlation. So therefore, you cannot say, hey, correlation means causal relationship. And so it's very important for you don't assume the causal link. However, if you pay attention on nowadays media, they very often they like to say, hey, this researcher find a relationship between A and B, and if you eat A, you're going to cause cancer. Nobody can prove that, right? It's just finding the causal correlation. So the correlation is not equal to the causal relationship. Okay, so next, pitfall 6 is generalization to individuals. So always need to avoid reading too much into statistical generalization. And so here I give example. As you look at any Wikipedia, they will talk about every country men are taller than women. So it means on average, in general, right? So when you go into the classroom, you cannot say, oh, every classroom, all men are taller than all women. So that's not the case. So that is, you are using the generalization to individuals. So when you go into the classroom, you can say some male students are shorter than the females, some female student, right? So in general, men are taller than women, but we cannot say individually that's the case. So that would be the pitfall 6. And pitfall 7 is called unconscious bias. So be careful about unconsciously or subtly allowing bias to color handling of data. So for example, heart disease in men versus women. Then the symptoms in men are more obvious than in women. So therefore, you cannot say, hey, men is more likely had a heart problem than the women. They're just more likely to have the more obviously symptom. Okay, so unconscious bias. And the next is the pitfall 8 is about significance versus importance. So when in this class, we're going to look at statistical significance. When you have statistical significance, one of the things is when you have larger sample size, even the small difference will be significant. So that is the weakness of the statistic significance. However, does that really mean that difference are very important? It might not be. So here, that's what we've mentioned. Statistical significant effects may lack practical importance. So for instance, Australian military recruit born in the spring average 0.6 centimeter taller than those born in the fall. It will be significant if you have larger sample size. But does that really matter? 0.6 centimeter differences will really make a military losing the battle or something? So of course. So you always need to understand as you calculating the statistical significance, you also need to look at called the practical significance. So basically, it's measure the importance of the difference. Okay. So that is the end of our last learning objective related to the pitfalls of the statistic. As we're going through this 8 pitfall, hopefully help you to grow your critical thinking ability as you look through nowadays news report. Always question about the statistic they show you on the news report. Do they fall in one of the pitfall here? Hello everyone, now we're going to work on the practice question related to our 5th learning objective, the statistic pitfalls. So we total learn 8 pitfalls. So in these practices, we're going to look at for each scenario, which one or which ones pitfall are being checked. Okay, so let's look at question number 1. A lottery winner told how he picked his 6-digit winning number, 5, 6, 8, 10, 22, 75. So it seems like these 6 numbers all have meaning. The 5 means the number of the people in his family. 6, 8, maybe the birthday of his wife, and then school grade of his 13 years old daughter, and the sum his birthday date and his wife's, and the number of the years of the marriage and the year of his birth, 75. So he said, I try to pick numbers that mean something to me. Okay, so based on your understanding of how a lottery works, would someone who picked 1, 2, 3, 4, 5, 6, because it's easy to remember, have a lower chance of winning? Okay, so the answer is no. So regardless you pick 5, 6, 8, 10, 22, 75, that has meaning, or 1, 2, 3, 4, 5, 6, that doesn't, it's just easy to remember, they had equal chance to win. So for the lottery, it does not mean you pick a complicated number, you have a higher chance to win. So you guys had exactly the same chance to win. Okay, so therefore the answer for this one is no. And so if for someone thinking that is not the case, it's because they are go falling through this called the conclusion from rare events. Okay, conclusion from rare events. They are thinking, hey, because this guy picked a unique number, that's why you win. I'd better pick some unique number. So when you're thinking about that, you are using the rare event to thinking that can be generalized. So that's not the case. Okay, question number 2. Bob must be rich. He is a lawyer, and the lawyer makes lots of money. So this statement best illustrates which pitfall. 1, using poor survey method. Nothing about survey here. Confusing significant with the important. We didn't look at any differences here, so we cannot pick 2. 3, unconscious biases. Here I want to call it out, when we're thinking about bias here, we're mainly focusing on the demographic biases like race, gender, age. And here is not related to race, gender, age, so therefore it cannot be 3. And number 4, generalizing from an average to an individual. So that is the pick. Why is that? So on average, lawyer is the profession, make a lot of money. But if you know a lot of lawyer, you will know that not all the lawyer make a lot of money, especially the lawyer just started career, so they don't actually make that much. Okay, so therefore, what the mistake Bob we are making here is assuming Bob had a lot of money because on average the lawyer make a lot of money, but it doesn't mean Bob are making a lot of money. So the mistake here we're making is that generalizing from an average to representing individual. Okay, the last example here. A national health interview survey conducted by the U.S. Center for Disease Control and Prevention report that using a cell phone instead of the landline appeared to double a person's chance of binge drinking. And I guess I'd better give up my cell phone, said Bob, so that he can stop binge drinking. Do you think he's right? So the answer is not. So what are the problems he's facing? What pitfall? So first of all, very obviously, the CDC didn't say using the cell phone caused the people the chance go up of binge drinking, right? They just find a correlation. So the first mistake, very obvious, is called assuming the causal link from the correlation. Okay, and then the second is that CDC is survey a bunch of people. The conclusion is from a general population, from an average result. And then Bob said, hey, that's going to apply to me, right? So that's not the case. So therefore, it also meet the pitfall 6, generalization to individuals, from generalizing from average to individual. So that is the mistake as well. So that means even the CDC find a causal relationship, but you cannot, based on that result, say, hey, that's going to apply to Bob, right? So that individual. So therefore, for this practice question, we're going to pick 2 and 3, assuming a causal link and a generalization to individuals. So hopefully, this practice question allow you to better understanding the 8 pitfalls we just covered, and you're going to see more practices in your homework on the learning platform.